So in this problem, we are asked to compute y of t, the output of this LTL system that is characterized by its impulse response h of t given graphically here. So x of t, y of t will be x of t convolved with h of t. So what I'm going to do, I am going to break the input into two functions, x1 and x2, x1 and x2. So -1, this is 2, this is x1 of t, and then x2, which is this. So x2 of t, so this is 1. So then I can write x of t as x1 of t plus x2 of t. So because the system is linear, so satisfy the additive property, so then the output y of t will be x1 of t convolved with h of t plus x2 of t convolved with h of t. Now, so I can find a relationship between x1 and x2. So x1, x2 expressed in terms of s1. So x2 of t is equal to x1 of t shifted to the right by 1, and then when they get the amplitude. Okay, so because the system is linear and time invariant, so once I know the output given by x1, so I can call it y1, then y2 of t will be equal to minus y1 of t minus 1, because the system is linear and time invariant. So when I scale the input by -1, the output must be scaled by -1, and when I shift the input by 1, the output will be shifted also by 1. So I am going to compute one of these convolutions integrals, and then I'll just obtain the overall by using the fact that the system is linear and time invariant. So let's compute x1 of t convolved with h of t, which I will call y1 of t. So we're going to do this graphically. So y1 of t is given by the integral from -infinity to +infinity, x1 of t minus tau h of tau d tau. Now h of t is so the rise, so it's in the form mx mt plus b. So m, which is the slope, the rise is 1, the run is 2, so is half t, and the graph goes to the origin, so plus 0. So h of t is half t. Now, so since we're doing this graphically, let me sketch x1. So we have x1, which is this. So x1 of tau. Now, so x1 of negative tau is the time reversal of x1. So it's this. It's 2, 2, 1. Now, in step 3, we are going to sketch so we're sketching x1 of t minus tau. So we just add t to this point. So we have t and t plus 1. Okay. Now, don't lose sight that this axis is tau. The horizontal axis is tau, and this is 2. So now we are going to start the convolution operation. So this gives me t plus 1, and this is 2, and this is h of tau. This is x of t minus tau, and this is the origin. This is tau. So we're going to distinguish a few cases. So as you can see, y of t is the convolution of, so y1 of t, which is the integral from negative infinity to plus infinity, x1 of t minus tau, h of tau, d tau. So what we're going to do, we are going to move the x, because that's the one that is shifted from negative infinity to plus infinity. So when t plus 1 is less than 0, right? So let's say case 1. Then what happens? So there's no overlap of the two graphs. So that means x1 t minus tau times h of tau is equal to 0. So this implies that y of t, y1 of t is equal to 0. So when t is less than negative 1, y of t, y1 of t is equal to 0. So that's the first one. Now, case 2, is going to be this scenario where t is less than 0 and t plus 1 is bigger than 0. So we have this scenario where we have h of t 2, so h of tau, and then we have this case, so t here, t plus 1. So then the overlap is here. This is 2. This is 1/2 of tau. So in this case, we have -1 less than t less than 0, and x of t minus tau, h of tau is equal to 2 times 1/2 of tau when tau is between 0 less than tau less than t plus 1. So y1 of t for this case is integral from 0 to t plus 1 of tau. So when we integrate, it's a d tau here. So when we integrate, we have tau squared over 2, taken from 0 to t plus 1. So that gives me t plus 1 squared over 2 minus 0. So for this case, we have y1 of t equal to t plus 1 squared over 2 when -1 less than t less than 0. So we have this case. Now, case 3. In case 3, this is the scenario. So we have this is h of tau, and the graph of x will be like this. So t and t plus 1, because the width of x1 is just 1 and the width of h is 2. So at some point the x is going to fit into the h, right? So x1 is going to fit into h. So x1 of t minus tau here, and this is h of tau, which is 1/2 tau. So for this scenario, we have t bigger than 0 and t plus 1 is less than 2. So that means 0 is less than t less than 1. And x of t minus tau, h of tau gives me 2 times 1/2 tau, which is just tau, and tau is between t is less than tau less than t plus 1. That's why we have the overlap. The overlap is here. So y of t is integral from t to t plus 1, and tau d tau, so that is 1/2 tau square t to t plus 1, so that gives me 1/2 t plus 1 square minus 1/2 t. Okay, square. So we can expand this and simplify, but I'm gonna leave it like that for now, and later on we're going to change that. So we have, for this case, have y1 of t, which is y1 of t is equal to 1/2 t plus 1 square minus t square over 2, where 0 is less than t less than 1. So case 4. So for case 4, what do we have? We have the h, which is this 2, and the x1 will be like this. So t plus 1, and the overlap is here. So the overlap is here. The overlap is here. Now, so for this case, we have t less than 2 and t plus 1 is bigger than 2. So in that case, we have 1 less than t less than 2, and we have x of tau, t minus tau, h of tau will be equal to 2 times 1/2 of tau, which is tau, and tau is between t and 2. So we can compute y1 of t will be integral from t to 2 tau d tau, so that gives me 1/2 tau square from t to 2, so that gives me 1/2 t square, which is 2 square, which is 4, minus t square, 1/2 of t square over 2. So for this case, we have y1 of t will be equal to 2 minus 1/2 t square, when 1 is less than t less than 2. So, and the last case, so case 5, what do we have? We have this scenario. this is 2, and we have this scenario t here, t plus 1. So in that case, when t is bigger than 2, there is no overlap. So y of t, y1 of t is equal to 0 for this case. So let's put it all together. So y1 of t is equal to 0 when t is less than -1. Then is equal to t plus 1 square over 2 from -1 to 0. So t plus 1 square over 2 when -1 is less than t less than 0. Then we have t half, so 1/2 t plus 1 square minus t square over 2 when 0 is less than t less than 1. And then we have 2 minus t half t square when 1 less than t less than 2. And then is 0 for t bigger than 2. That is y1. So y2 is equal to negative y1 of t minus 1, as we found above. So that means we have 0 when t minus 1 is less than -1. And then we have t square over 2, because I would replace t by t minus 1. So t minus 1 plus 1. The second term, give me t square. So if you like, I could write t minus 1 plus 1 square when minus 1 less than t minus 1 less than 0. And then we have 1/2 t minus 1 plus 1 square minus 1/2 t minus 1 square. So for this case, we have 0 less than t minus 1 less than 1. So we're going to recompute the bounds right after this. And 2 minus half t minus 1 square. So 1 less than t minus 1 less than 2. And 0 when t minus 1 is bigger than 2. So when I recompute the bounds, I am going to get 0 when t is less than 0, and then t square over 2 when 0 is less than t less than 1, then t square over 2 minus 1/2 t minus 1 square, which is 1 less than t less than 2. And the last one, 2 minus half t minus 1 square, That gives me 2 less than t less than 3, and that will be 0 when t is bigger than 3. So that is well, I need to put a minus in front of it, minus. Okay, so when I put minus inside the parentheses, when I put plus here, then this becomes minus, minus here, plus here, minus here, plus here. Okay, so now we just need to add y1 of t to y2 of t. So y of t is y1 of t plus y2. Okay, so these are piecewise functions. So we have to add the section that are in the same on the same interval. So when t, so y of t will be equal to, so the interval from negative infinity to -1 is the function will be 0 when t is less than -1, and then from -1 to 0 we have to add this. So there's nothing else that is from -1 to 0, so we keep that. So that is t plus 1 square over 2. That is -1 less than t less than 0. And then from 0 to 1, we have to add the two terms. So we have 1/2 t plus 1 square minus t square over 2, then minus t square over 2, which is from 0 less than t less than 1, and from 1 to 2, from 1 to 2 we have 2 minus half t square, and y2 is negative t square over 2 plus 1/2 t minus 1 square, which is for 1 less than t less than 2, and from 2 to 3, from 2 to 3, y1 is 0, so y2 is -2 plus 1/2 t minus 1 square, 2 less than t less than 3, and then it will be 0 when t is bigger than 3. Okay, so 0 when t is less than -1. So this is half t square plus t plus 1 when we are -1 less than t less than 0. And if you like, we could just keep it like that. So 1/2 t plus 1 square, and is the second one is 1/2 t plus 1 square minus t square, which is 0 less than t less than 1, and the last the one after that will be 2 minus t square plus 1/2 t minus 1 square. So we can expand and group the polynomial of the same order together. And the last one is 2 plus half t minus 1 square 2 less than t less than 3 and is 0 when t is bigger than 3. I'm gonna copy the output down here. I'm gonna paste it over here. So now let's sketch the output y of t. So to sketch y of t, this will just give a rough sketch of the output. So let's put some axes here. So this is y of t. So this is -1, this is 1, this is 2, this is 3. So let's say this is 0.5, that is 1. So now we know that for t less than -1, the function is 0, so it's 0. The function is 0. 0. Then at t equal to -1 is 0. So at t equal to 0, that's the other interval. So we have half t plus 1 when -1 less than t less than 0. So I'm gonna plug in 0 here. So it's half. So the value of the output at 0 is half. Now, and it's a parabola, and the coefficient of the parabola is t squared, which is positive. So it should be like that. Okay, something like this. And then, so let's look at the 1/2 t plus 1 square minus t square. That is from 0 less than t less than 1 less than 1. So at t equal to 0, we know that is half. At t equal to 1, then we have 1/2 2 square minus 1. So that gave me 4 over 2 minus 1. So that's 1. So at t equal to 1, the coefficient of the t square is negative. So that's the point. So it's gonna curve down like that because the coefficient of t square is negative. Now let's take care of the next one. So the next one gives me 2 minus t squared. I could simplify this, but it's just leave it in this form because it's easy to sketch. So that is 1 less than t less than 2. We know that when it's t equal to 1, it's going to y of t equal to 1. Now when t equal to 2, gonna sub that in here. 2 minus 2 square plus half 2 minus 1 square. So as you can see is 2. 2 minus 4 plus half. So it's -2 plus half is -3 half. So t equal to 2 will be -3 half. So -3 half, -1.5 will be somewhere down here. -3 half. So t equal to 2. So assuming it's going to be something like this. So the coefficient of t squared is negative, so it's gonna curve down. And then at t, so that's that one. And then the last one is we know that that must be equal to 0, right? T equal to 3 is 0, but let's check. So -2 plus half t minus 1 square. So at t equal to 3, you have -2 plus half 3 minus 1 square, which is -2 plus 1 half 4. So 2 minus 2, which is 0. So it's indeed equal to 0. So the graph will look something like this. It's gonna curve up because the coefficient of t squared is half in this case. Okay, so then 0 after that. So the function is 0 after that. So this is t. So that's y of t.